In some ways, I think I'm the odd one out here. We're hearing a lot about fuels and the effect of different fuel solutions on the energy consumption of vehicles. But I would like to pick up some of the things which Andreas mentioned about the light-weighting side of vehicles and what effect that has to the overall fuel efficiency and energy consumption. I think we can say that although the different fuels themselves have some benefits in some reductions in CO2, and you can compare different fuels all day, but really what we're trying to do is how do we get a real energy reduction? And one of the ways, and one of the main ways we can do that, is really just to reduce the weight of the vehicle. So although these fuels take us so far, one of the big changes is if we can take light weighting to its extreme, and we can get the secondary savings, and we can downsize in fuel trains, powertrains, there's everything there. We can see these things here where we can have a 50% weight reduction, giving a massive 40% energy saving. And we have studies to back that up across a range of vehicles. In terms of how do you actually get weight reduction? It's not something which is new. Work's been going on for sort of years on taking weight out of the vehicles. There's been a lot of work on, for instance, ultra-high strength steels, so work from the 90s and beyond, where they're taking actually fairly significant amounts of weight out of the vehicle structure. But they're still relatively heavy. And we've got up on the slide here, there's a few other technologies. People are looking at aluminium. For instance, Jaguar are pretty much predominantly aluminium in their body structures. But one of the things which Jaguar have actually said publicly is to meet their fuel economy challenge, they want to reduce the weight of their vehicles by a further 50%. That is already from an aluminium structure. And that has led them and others, as we've heard about the BMW I series, and there's a range of companies now looking at structural composites. Again, this is something which isn't particularly new. Composites themselves have been used in vehicle structures since about the 1950s. But what we're seeing now is mainstream automotive companies really trying to get the benefits out of structural composites. Indeed, myself sort of started actually with Ford sort of 20 years ago on high-volume composite structures, and we're only now seeing some of these things coming through. But I think one of the differences which is happening, again, with the I-Series, which are using carbon fibre, Jaguar have announced a new program looking at a carbon fibre body-structured vehicle. There's also, we're dealing with a number of OEMs from the Far East who are, again, looking at how do we get the ultra-low-weight structures. And there's been a huge amount of investment in Japan over the last years, again, in carbon fibre composites. But as you can see there, although you've got great weight reduction potential, one of the problems is the high piece cost associated with this, and how do you integrate that into the rest of the vehicle structure, and also the bit of a business case of the vehicle. And I'll say a few words on that as we go through the rest of this presentation. But one of the things that will draw your interest to there is, if you look at investment costs and you're comparing a typical steel stamping press versus a carbon fibre press, you do have a significant reduction in investment cost. And that's one thing which I think is important, which we'll pick up again. Carbon fibre. One of the things we do know about carbon fibre is it is expensive. And the material will remain expensive. Although there is a huge amount of effort around the world, in particularly there's some studies going on in the States and Japan, for the foreseeable future it will remain an expensive material. And if you've got trying to produce an entire vehicle structure out of carbon fibre, you end up with something which does still cost a lot of money. One of the ways which we're looking at reducing the cost of that, seems like a blindly obvious thing, we actually just use less of it. And we've got two ways of doing that. Firstly, is through vehicle design, but also we've got a technology as well which allows us to use carbon fibre just where it's needed in the production of carbon fibre beams. And I'll say a few words on that in some of the work we've been up to. The vehicle structure you see down on the right there is a full M1 classification car. So for those who don't really know what that means, that can go on the road. That is full type approved. Although we haven't done all the type approval testing at the moment, we have done the full simulations, and we've done enough of the testing to show that that actually works. The key bit about that is that vehicle structure weighs about 50 kilograms, which is probably about a third of a standard B-size car, which you see there. And then when you can get to these significant low weights, then you can start really putting a dent into fuel economy and also energy efficiency. In terms of the business case, the key part there is low-weight cars mean low energy consumption. But also the lower energy assumption assumes that we can downsize on the engines. And we've got a small range extender engine there just to show how small some of these engines are. And that is big enough to power a car of the sort of weights which we're talking about here. So we are talking about a bit of a change in the way which the traditional car which you see at the moment. But put it all together in a package and you've got something which really starts making sense. Come back to the low investments which I was talking about before. One of the things which we've heard a few times is electric vehicles do tend to be on slightly lower volumes than the mass market at the moment. And this is where the lower investment required for the carbon fibre presses, for instance, compared to the traditional steel stamping comes into play. What this allows you to do is to have a low investment, which means earlier profitability and an overall much more profitable production line for those types of vehicles. So we're seeing, I think that's really what we're seeing maybe in the case of the BMW side and maybe the Jaguar side as well. Overall, we can actually make a business case for a carbon fibre vehicle structure against current technology, and we can do that today. The other part about, I was saying, the business case, just before I go into conclusions, is because they're lower weight, we can use fewer batteries. And one of the studies we've done, again, with Far East OEMs, we effectively showed that we could save 4 kilowatt hours of batteries for the same range. And then, as we know, with battery costs, that has a big bearing on the overall business case and cost of the vehicles. The key points I'd like to say at the moment is the carbon fibre vehicle technology and structures which we see here are actually available today, and we can produce those. We have the analysis capability and we have all of the backup to allow us to produce production cars. And that allows these carbon cars to be made cost effective today. But as I say, we are starting to see those coming through, and that is an area which I think will accelerate over the next maybe 5 to 10 years. The last part on there is the effects of lightweighting is at least as important as the effects of new fuels. And I don't want that to be forgotten today. And one last thing, the vehicle structure which you see there is actually part of the Made in Britain exhibition over in the Science Museum. I'm not totally convinced that having my work in the museum is a great endorsement, but I think it is it's looking to the future, and it is showcasing not just future technologies from a range of companies, but also identifying Made in Britain. So for that, thank you very much.